Hi, my name is Andrea Ventola. I'm a PhD student here at the University of Michigan, and today we'll be performing the specific gravity test. First, you want to make sure you're wearing your safety glasses before starting the experiment, and I will be referencing the lab manual throughout the test, and I encourage you to do so as well. We'll begin by going over the equipment we need for the test. We have a 500 milliliter volumetric flask. We have a scale. We have a thermometer, a stopwatch, a funnel, the aspirator device, and some room temperature deionized water. And lastly, we have a 150 gram sample to perform our test. The first step in the procedure is to fill the 500 milliliter flask almost all the way up to the top, to the full mark, using the bottom of the meniscus as an indication. So we'll go off screen and fill this up almost all the way to the top, and then I'll show you as I fill up right to the preferred mark. I filled up most of the flask with deionized water off screen, but we'll top up with the squeeze bottle. And you want to make sure that you fill up enough so that the bottom of the meniscus of the water in the flask is reaching the marked point on the flask. That aside. So the next thing to do is to de-aerate the water in the flask before adding your sand. And before I turn on the device, I'll explain what happens. So put the stopper on. And when I turn on the device, it's basically removing any trapped air particles within the water in the flask. So you'll see when I turn on the device that the air bubbles that are trapped in the bottom here are moving their way up and out to the flask. So we'll be running this for 7 minutes, so you want to have a stopwatch handy when you start. So the flask is on, stopwatch is ready, and now we can start going. So we'll come back in 7 minutes. As deaeration occurs, you want to lightly tap the flask on the tabletop just to help aid the air bubble removal. So the 7 minutes are up of deaerating. So now what we want to do is uncork this. And because we've removed some air from the deionized water, we have to slightly touch up the amount of deionized water in here just to bring it back up to the meniscus height. Okay. And then we're going to repeat the deaeration process, but only for 1 minute this time. Okay, so the next step is to weigh this flask with the deionized water. Next, we want to pour out about half of this deionized water to make room for our sand. We're going to carefully funnel in the sand. Next, we want to refill up to the desired height with the deionized water. making sure we clean off the sand that's stuck up here. Next, we are going to deaerate this mixture now, this time for 10 minutes. So the ASTM standard notes that you want deaeration to actually occur longer, so 2 hours is usually what the standard notes, but for the sake of time and for this experiment, we'll be doing it for 10 minutes. So I'm going to get your stopwatch ready, and you can begin the deaeration. Now that the 10 minutes are up, I'm going to take the stopper out. And just like before, we're going to add a little bit more deionized water back up to the described height. And again, we do that just because during the deaeration process, air is removed, so it's been replaced by the water, so the water height is lowered a bit. We're going to replace the stopper back on again, and we're going to deaerate now, just this time for 1 more minute. Now we remove the stopper and we can record this weight. We can set this aside, and the final thing we want to do is record the temperature of this deionized water that we used for our test. So you want to make sure that the tip of the thermometer is not touching the sides, because that could be slightly different temperature than the water itself. So we can let it sit in here for a moment. Record this temperature. And we have finished the specific gravity test.